Dear students, in previous lecture we discussed the derivative, how to find the derivative of a function which is of the form of x raised to power n, and the derivative of x raised to power n which we proved is nx raised to power n minus 1. Now today we are going to discuss derivatives of trigonometric function like sin x, cos x, tan x. We will discuss the derivatives of these functions one by one. Now if the given function is f of x equals to sin x, then we have to find its derivative. That is, we have to find f dash of x or df by dx at arbitrarily x or at arbitrarily point. We know that the derivative at any point is f dash of x, f dash of c equals to df by dx at x equals to c is limit x tends to c f of x minus f of c upon x minus c, provided this limit exists. Now for existence of limit, we have left limit and right limit for this limit x tends to c. When we have left and right limit, so accordingly we have left derivative, that is L f dash of x, which is actually limit x tends to c negative of this very function f of x minus f of c upon x minus c, and right derivative for this is when we approach x from positive side, that x tends to c positive f of x minus f of c upon x minus c. This can be written as limit h tends to 0 f of c minus h minus f of c upon minus h, or limit h tends to 0 f of c plus h minus f of c by h. Now at any point, if the given function is derivable or the derivative exists, then we can simply write f dash of x or df by dx as limit h tends to 0 f of x minus h minus f of x upon minus h, or f of x plus h minus f of x upon h. Here we will derive, or we will find these two derivatives one by one. That is left derivative, which is actually limit h tends to 0 f of x minus h minus f of x upon minus h. Now f of x is sin x, which implies that f of x minus h is sin x minus h minus sin x upon minus h. Now here we have sin a minus sin b by using this, which is twice cos a plus b upon 2 sin a minus b upon 2, where a is x minus h, b is x. So it is limit h tends to 0 twice cos x minus h, that is a, plus b, which is x upon 2 into sin a x minus h minus b, that is minus x upon 2 upon minus h. Now 2x is 2, x plus x is 2x minus h upon 2. Now x cancels, it is simply sine of minus h by 2, but sine of minus theta is minus sine theta, which implies that it is minus sine h by 2. Now this minus in numerator will cancel with this minus in denominator, so we simply get twice cos 2x minus h by 2 into sine h by 2 upon h, or we can write this 2 in the numerator as h by 2 in the denominator. Now here we have two functions. One is cos 2x minus h upon 2. Second one is sin h by 2 upon h by 2. Also we know that the limit of the product equals to the product of the limits. So we can write this as limit h tends to 0 cos 2x minus h upon 2 into limit h tends to 0 sin h by 2 into h by 2. Now when h approaches to 0, h by 2 also approaches to 0. So this means that this is the standard limit and its value is 1. That is 1. Now here h at h equals to 0, this cos is defined, hence its limit is simply by replacing h by 0, that is cos 2x minus 0 upon 2, which is simply cos 2x upon 2, that is cos x. Similarly, right hand derivative, that is or f dash of x, is limit h tends to 0 f of x plus h minus f of x upon h, that is limit h tends to 0 sin x plus h minus sin x upon h. Now again using sin a minus sin b, which is twice cos a plus b upon 2 into sin a minus b upon 2, we simply get limit h tends to 0 2x cos 2x plus h upon 2 into sin h by 2 upon h by 2. Now again using product of limit equals to limit of the products, it is limit h tends to 0 cos 2x plus h upon 2 into limit h tends to 0 sin h by 2 upon h by 2. Using the standard limit, we simply get twice cos 2x plus 0 upon 2 into 1, that is 2 cos 2x upon 2 cancels, it is simply cos x. This means that right hand derivative equals to left hand derivative, hence its derivative exists, because limit x tends to c f of x minus f of c upon h x minus h, which is actually the definition of derivative, exists. So this means that we can simply write f dash of x equals to cos x, or df by dx, or d by dx of sin x, that is derivative of sin x is cos x. Or similarly we can prove that derivative of this cos function, that is df by dx of cos x, is minus sin x. Inshallah, in tomorrow's video lecture we will discuss the derivatives of tan and cot function. So thank you.